Guys, it's Mrs. D. I'm going to take you through a few things with mole conversions. And the first episode of this is mole conversions using Avogadro's number. So we're going to convert from moles to atoms, particles, molecules, or formula units, and then back from those back to moles. And so to do that, you have to have Avogadro's number as your vehicle. So this first little step I want to show you is if you look up here, you have Moleville in the middle. And so our vehicle, we're going atoms, molecules, particles, formula units. And notice we're using Avogadro's number. Remember, Avogadro's number is 6.02. Let me find my pin here. There we go. Is 6.02 times 10 to the 23rd, and that is atoms, particles, formula, or formula units per mole. Okay, so it's whatever per mole. Okay, that number is on the back of your periodic table, but it is something that you'll probably memorize anyway. So let's go to the questions. We want to know how many molecules would be present in 4.2 moles of glucose, which is C6H12O6. So the best way to start this is to determine from your problem what you have, which you're given 4.2 moles, and what you're looking for, what you need, and that is molecules. So when you do these types of problems, I know right now it seems really simple, but I want to show you this method. And if you continue to do this method with dimensional analysis, you're going to be a lot more successful when it does get really tough. So the first thing you do is you always start with what you have, which is 4.2 moles of glucose. Now what you're going to do is set up a dimensional analysis. And so I'm going to go from moles to molecules. And so that's where I use Avogadro's number. So for every 1 mole of glucose, which is C6H12O6, I have 6.02 times 10 to the 23rd molecules of glucose. So glucose molecules, I have that many. So what I do is when I punch this into my calculator, I want to use, it's real important that you use the parentheses when you punch it into your calculator. So it's best on a scientific calculator that has parentheses. So I'm going to punch 4.2 times, and there's two ways to do this. You can do times, let me write it out here, 4.2 times parentheses 6.02 times 10 and your little caret 23 end parentheses. What I like to do is I type in 4.2, and on a lot of calculators it's a second function, but you're going to look for an EE button. You're going to hit that EE button, and then you put simply the power in which your 10 is raised to. So, I'm sorry, 4.2 times, you got to do 6.02. EE, and then 23. So this actually like eliminates, you don't have to put those parentheses around there. It kind of eliminates that. So that's a possibility too. So I want you to try both ways. Just determine which way you're most comfortable doing. And like I said, the EE button is typically a second function on your calculator. And after punching this in, you should have gotten 2.53 times 10 to the 24th. And that is the moles cancel. And so you're left with molecules. So this is molecules of glucose, C6H12O6. Okay, let's try another one. This time, there were 3.54 or 45 times 10 to the 22nd atoms of copper in a sample. How many moles of copper is this amount? So here's your have. This is what you know you have, and that's 3.45 times 10 to the 22nd atoms. Now we want to know this is what we need for moles. So we're going to go again from atoms to moles. So we're going to use Avogadro's number. We always start with what we have, 3.45 times 10 to the 22nd atoms of copper. Now this time I want you to see where I'm putting Avogadro's number, because I know that there's 6.02 times 10 to the 23rd atoms of copper in 1 mole of copper. So notice I put the atoms on the bottom because I have to have basically be catty-corner from each other. So therefore you can cancel out the atoms. Then you're going to have mole. So what you do is you always multiply across the top, multiply across the bottom, and divide by 2, or divide by the 2. So basically you're going to take 3.45 times 10 to the 22nd divided by 6.02 times 10 to the 23rd, and you'll get your number of moles. There's 2 ways to punch in your calculator. The first way would be parentheses 3.45 times 10 caret 22 end parentheses divided by parentheses 6.02 times 10 caret 23 end parenthesis. Or if you wanted to use the EE, you could do 3.45 EE 22, that's the power it's raised to, divided by 6.02 EE 23. Again, if you want to try both of those out just to see what you're more comfortable with, I think that would be a good idea. So either way is fine. We're just ultimately getting to the final answer. So if I punch that in my calculator, I'm going to get 0.0573. Now, you guys, this is why I kept so many numbers, because look, I've got 3 sig figs here, so my answer must have 3 sig figs, and that first 0 is a leading 0. So therefore, I have 0.0573 moles of copper. So I have less than a mole of copper, which makes sense because I have less than 6.02 times 10 to the 23rd to start out with. Let's try one more. How many moles are 4.78 times 10 to the 24th formula units of calcium carbonate? Oftentimes, formula units are used for ionic compounds. So our have is what we're used to here, what we need. And our need is how many moles? So we start with the number we have, and that's 4.78 times 10 to the 24th. And that's formula units. Be careful how I put form u. It's better that way to put form u. Okay, so just like formula units, it's in the same category as atoms. So we have a good old 6.02 times 10 to the 23rd formula units of calcium carbonate, CaCO3, for every 1 mole of calcium carbonate, CaCO3. Therefore, I can cancel my formula units, and I'm going to end up with moles. So essentially, I take this across times, and I divide by the bottom. So I'm going to take 4.78 times 10 to the 24th divided by 6.02 times 10 to the 23rd. Again, me personally, I like to put in 4.78. I like to use the EE button or the exponent button to the 24th. And then I'm going to divide by 6.02 EE 23. So I want you to punch out in your calculator and make sure that you know that we get the same idea, or we get the same answer here. So 23. All right, so my answer is definitely going to be more than 1 mole. And so I actually have 7.94 moles of calcium carbonate. Now let's think about, is that reasonable? Well, 10 to the 24th is quite larger than 10 to the 23rd, so that's absolutely reasonable. All right, this is the section. Again, let me go back to this right here, the section from going from atoms, molecules, particles, and formula units to moles and back again. Join me for the next video, and we'll do moles to mass, mass to moles.